Today we're going to talk about how to convert not points but lines from algebra form, xy form, to trig form, which is r and theta. Okay, first we'll talk about things that are non-linear, okay, parabolas, circles, etc. So x in algebra is the same thing as cosine in trig, so it's r cosine theta. Y is the same thing as sine in trig, so it's going to be r sine theta. Okay, so r squared cosine squared looks exactly the same thing as this except squared. So if I ever see this, that's the same exact thing as x squared back in algebra 1. So r squared sine squared theta is nothing more than y squared. Then finally, r squared is nothing more than x squared plus y squared. That just comes from the magnitude, the Pythagorean theorem. So again, my objective for this part is if I have something in algebra mode, in other words, I see x's and y's, my job is to get rid of those and turn everything into r's and thetas only. If I see anything in r's and theta mode, which is trig mode, I have to get rid of all of those and end up with nothing but x's and y's. Okay. And then the next one we're going to talk about, which seems kind of tricky at first, but it's not too difficult, is what happens if we're dealing with linear equations. So take a look at ax plus by equals c. That's a straight line back in algebra 1 in standard form. Okay, all I have to do is recognize this new format of a straight line in trig mode. Okay, so this p here and this phi here is my objective. This is what I'm trying to find. So p, I like to think of it as the magnitude and phi as the direction, because those are things that we are familiar with. Okay, so my first objective is, if I gave you a line in algebra mode, how do I find the p and the phi in trig mode? So again, when I say magnitude, it's virtually the same exact thing as what we did before, except instead of x's and y's, we have to use the numbers in front. So I'm going to say a squared plus b squared. Okay, x's and y's are more variables, placeholders. And the only tricky part is you got to remember the c that actually comes into play. That's your numerator. The logic behind that, you don't really have to understand, but it's kind of like when we did the magnitude of a vector. It's kind of the same idea. But again, just remember magnitude on the bottom, that c is on top. And then the phi, this should be easy. This is going to be very familiar for us. It's always going to be arctangent, but instead of y over x, we just use b over a, which is virtually the same thing, just the numbers in front. Of course, make sure you are always in the proper quadrant. Okay, so once again, if you're in quadrant 1, your answer is correct. If you're in quadrants 2 and 3, add 180. If you're in quadrant 4, add 360. Okay, so that's how we go from algebra to trig mode. Now let's go backwards. What if I give you p and phi, which is trig mode, and you have to convert it into algebra mode? This one is even easier. Remember, x is always the same thing as cosine, but instead of x, we're going to be a. So a is nothing more than literally just cosine of phi. Y is nothing more than sine, so instead of y, we're just going to use b. So all you have to do is take sine of your angle. And c is so easy, you can't get this wrong. It's literally that value p staring right at you. That's it. So if I gave you ax plus by equals c, your job is to find this p and this angle. If I gave you p and phi, your job is to find a, b, and c. A is cosine, b is sine, c is staring right at you, p.